Hey guys, welcome back to my channel. Thank you very much for joining me for this video. We are going to be explaining how to calculate your z-score for your normally distributed data. So here we go. Okay guys, as I mentioned, I'm going to be explaining z-score for a student of mine who needs some help. So basically z-score tells you how far you are above the mean of a set of data when your data is fully standardized, meaning everybody's on the same par, making your mean at 0. You move 3 above the mean and 3 below the mean. So when the data is normally distributed, we say we standardize the score by converting it to z-score, and my board is messing up right now, so I'm gonna have to go back to that slide. Alright, so we convert the z-score of your data set. Alright, so when you think about converting your z-score, you first need to know that when it says normal distribution, your data is symmetrical, where you have a bell curve and the center is the mean. And once the data is standardized, we basically saying everybody is at the same point. So the mean is now 0, and you move 3 standard deviations above the mean and 3 standard deviations below the mean. Alright? And we do this because of the 68, 95, and the 99.7% rule that basically covers majority of the data within 3 standard deviations of the mean. As you know, the area under the curve is equal to 100%, but we only account for 99.7% with our 3 standard deviations. So the other 3% will 0.3% will be whatever is left outside of 3. Okay? And so the 68 represents 1 standard deviation, so between -1 and +1. The 95 represents 2, so that's between -2 and the +2. And the 99.7 represents 3, which is between -3 and +3. So very soon we'll get into that. So the example says calculate the z-score for a test where a person received an average score of 80, so the average score was 80, and a standard deviation of 8 points. So we need to know the z-score formula, and the z-score formula is z is equal to x minus x bar over standard deviation. The first x here represents your data value, or you say your actual score. The x bar represents the mean, which is the average score, and this SD represents the standard deviation. So once we know our mean, we know our standard deviation, we have to be given the actual score to find the z-score. So they're saying that if you got a score of 96, what is your z-score? So given that the average is 80, so x bar is equal to 80, standard deviation is equal to 8, and the actual score is 96. So having these 3 data values here, we're going to put them into the formula, the z-score formula. So let's go. So we're going to have 96 minus 80 divided by 8. So z is equal to 16 over 8, which is equal to 2. So this person is performing at 2 standard deviations above the mean with a score of 96. Very soon I'm going to show you what that looks like graphically. They're saying that your friend got 76 on their test. So what is their z-score? So we'll do the same thing. So since that is the same class, we're going to use the same average and the same standard deviation. Only thing that is different is going to be our actual score. So z is equal to the data value, so that's x, minus the mean divided by standard deviation, which is 8. So let's fill this in. So that's -4 over 8, which is equal to -0.5. Let's represent this data on our bell curve so you guys can see where they're standing above and below the mean. So that's 0, 1, 2, 3, -1, -2, -3. Alright guys, so there are two ways of doing this. So with your actual score, your average and your standard deviation, you could have drawn your bell curve using the numbers you're given here. So 80 could have gone in the middle right here, and you could have had add the standard deviation to your right, so that would be 88. That would be 96. 96 plus 8 would be 104. If you're subtracting to your left, here you would have 72. 72 minus 8 will give you 64. Give you 64. 64 minus 8 would give you 56. Alright? And so you could use your actual score or your standardized value, which is 0, 1, 2, 3, 0, -1, -2, -3. Alright, so with that said, we just found that the first person had a z-score of 2, which made the person be right here. Let's change the color. So the z-score of 2 would be right here. Okay? So this person is performing better than 95% of the people, or 97.25% of the people. How do I know that? Because between 2, it's your 95%, and this person is performing within 2 standard deviation, alright? Okay, and so the 0.5 negative would be somewhere right here, and so 76 is going to be somewhere right here. And that gives us a negative 0.5, and this gives us a 2. So that's what it basically looks if you should draw your bell curve to show this data. Very soon you learn how to find the area above, below, and between two z-scores, but for now, that's what it basically looks like. Another thing to pay attention to is the value of your z-score. So if it's negative, you know it's going to be somewhere on your left side, so that's below the mean. If it's positive, it's going to be somewhere above the mean. So that's something to look for as well before you even start calculating your data values. So this one said, what test grade has a z-score of 1.5? So let's go back to where we were. This board keeps going back to where I don't want it to go back to. So I don't know what's going on with it, but we're going to forget about that. So it's a z-score of 1.5. So 1.5, you could have two ways of doing this. It's going to be between 88 and 96. So I know my number should be between some of those two. So there are two ways. You can either have the z formula to work this. So z is equal to x minus x bar over standard deviation. We know the mean was 80. The standard deviation was 8. And since our z-score is 1.5, we can put the 1.5 right here and find the data value. That's one method. Another method is to draw your bell curve. So that was 80, that was 88, that was 96, that was 104, this was 72, this was 64, and this was 56. Another way to do it is to identify your 1, 2, 3 positive, negative for your z-score. Alright, so if you do that, you know you're moving 8 for every z value. So in this case, since that is 1.5, it has to be somewhere between 1 and 2. Right? It has to be somewhere between 1 and 2 right here. And since that is 8 apart, half of 8 is 4. So here would be 88 plus 4 to give me 92. So we say when z is equal to 1.5, x is equal to 92. Alright, so that's what we get from our graph. Let's prove it with calculation. So since as on this side, they are, let me bring it over some more. So 1.5 is equal to x minus 80 over 8. So since as we're trying to find the value of x here, we must first simplify by multiplying both sides by 8. So 1.5 times 8 will give us 12. So we times 8 here, times 8 here. And we do that because we're dividing here for a fraction. So to cancel the denominator, we have to multiply by the denominator. on both sides to balance the fraction. So is that so this 8 cancels that one, is equal to x minus 80. We need to add 80 on both sides, so 12 plus 80 is 92. So 92 is equal to x. As you can see, through calculation or the graphical method, they give you the same thing. So once you know your standard deviation, you can always find half of that to know what 1.5 above is or 1.5 below is, alright? So you have two methods of doing this. If your teacher did not say show working, you can use any of these two methods because they can't give it to you incorrect. So a question, Sam is asking, a teacher calls home whenever your z-score is less than negative 2.0 or negative 2. What score earners are called home? So what you basically do is to examine your z-values and your raw data on your bell curve and look for negative 2. So negative 2 is right here at 64. And the statement is asking you what grade warrants your call home if your z-score is less than this. So you basically say scores less than than 64 would warrant your call home. Because these values would be less, says all of this region, it will be less than negative 2 standard deviation or negative 2 z-score. Let's use the word earn. Alright guys, and so I hope this was useful for the person who asked me. They asked me not to call their name, so I'm not going to mention their name, but yeah. This was what I explained in class and it wasn't clear. So there you go, I hope it's better for you, and if it is, leave me a comment so I know, and if you need more clarification, I'll be definitely happy to help you. But that's the end of this live stream, and I'll see you guys on another video. Remember to leave your comments if you have any, or if you have any concern, or if you have anything you want me to help you with, feel free to leave them. I'll be happy to help you.